Hello everyone, welcome to the study guide for prerequisite chapter 1. We'll go ahead and get started with A here. This is on simplifying using your laws of exponents. This first one here, I noticed that I have a -4 on the outside of parentheses. I have a -2 here on the outside of the parentheses. So I'm going to start off by multiplying in my exponents. So here we have our exponents multiplied, and now I need to evaluate. I have same base in the numerator and denominator. X is on top and bottom, Y is on top and bottom, and so I need to rearrange. Alright, so I just rearranged so that we have no negative exponents, and from here, if we have 12 x's up top and 8 on bottom, we subtract. To find the difference, we have 4 x's, and if we have 12 y's on top and 8 on bottom, we subtract, and we find that we have 4 y's on top. Let's do the next one. So part B, this one, first thing I noticed, that I have parentheses, and I don't have any exponents on the outside of the parentheses. So I can start off by just writing everything with one fraction. I'm going to multiply across the top and across the bottom, and then simplify from there. Okay, so up top we have a 3 times 4, which gave us a 12. We have an a to the third, and then we have a b to the first times a b to the second. That gives us 3 b's here. And then we have 2, and then 2 a's multiplied times 2 a's. We have a total of 4 a's, and then 3 b's times 4 b's gives us a total of 7 b's. And at this point here, we have a 12 divided by 2, which is 6. And if I have 3 a's over 4 a's, well, we subtract, and we're going to have 1 a down below. And we have 3 b's over 7 b's, we subtract, and we have 4 below. Okay, so let's finish up with problem C, 1C. This is actually the one from your quiz. I see that I have a -2 on the outside of my parentheses, but before I do anything, I want to simplify the inside. I want to simplify that picture, and then I'll deal with that -2 on the outside. Okay, so what I've done on the inside is I've divided 10 over 2, which is 5, and I got rid of my negative exponents. I crossed the line and I changed the sign of my exponents. This makes the problem pretty easy for me to look at, because I see that I have 2 x's, 3 x's, and then 7 x's, which gives me a total of 12. And then if I have 2 over 4, cross off 2 of them, I'm going to be left with 2 y's down below there. And so now all I need to do is multiply in that -2. Okay, so here I have multiplied in, and then I crossed the line and changed the sign and rewrote without any negative exponents. Okay, I'm taking a long time. Let's jam to the next one. We want to write the standard form equation of a circle, so we have to first know what that is. And remember, that's directly related to the distance formula. So at this point, here we have our standard form equation. We need to identify the h and the k and then the r, and simply plug everything in from there. So I plugged everything in, cleaned it up a little bit with the negative next to the negative. I got a positive, and 5 to the second, I got a 25 there. So let me jam to the next problem here. I got a limited time. We want to rewrite the expression without using the absolute value symbols. Okay, so let's think about what these are in terms of decimals, and then work backward from there. Okay, so the absolute value of 4 minus the square root of 5. First of all, the square root of 5 is less than the value of 4 here. And it is approximately equal to 2.23. If we subtract these values, it gives us a positive 1.77, and the absolute value of that is just going to give us a 1.77. So really, all we need to do is write 4 minus the square root of 5 to give us our answer, rewriting without the absolute value signs. So this next one here, we have pi minus 4. Well, that's going to result in a negative value because 3.14 is equal to pi. So we have a negative value that's going to result on the inside of our absolute value here. And then we take the absolute value, and that comes out positive. So my goal is to get a positive 0.86 somehow by rearranging the pi and the 4. And if I were to just flip those guys around, the 4 and the pi, that would result in a positive 0.86. And so I can just rewrite this without the absolute value signs with the 4 minus pi there. Next problem relates to the distance formula. We want to find the distance between the 2 points. You could literally plot those 2 points on the xy system and then use the Pythagorean theorem to figure out the distance between those 2 points, or you could just rely on this handy-dandy formula here and identify your x1, your y1, your x2, y2, which I'll do here. So after plugging in our points and simplifying, we get the square root of 106. And 106 has no doubles in it. So let's just move on to the next problem, which involves the distance formula and the Pythagorean theorem to determine if the points make a right triangle. Okay, so this one, let's actually plot the points. Let's get a visual of what's going on and try and make sense out of it. Okay, so I have plotted my points, and I need to figure out, does this make a right triangle? If it does, then it's going to follow the Pythagorean theorem. So I want to figure out my sides here, and then I can plug in my A and my B and my C into the Pythagorean theorem formula, and if it's true, then it does make a right triangle. So let's start off with the easiest one. Here I'm going from -3, 4 to 5, 4. Well, we're going in a straight line, so we could just figure out the distance between -3 and +5, which is an 8. That was easy. Let's go ahead and figure out this distance here. Well, this distance here, I'm going to make a right triangle here, and this is a 2, and from 0 to 4, that's a 4, and 2 squared plus 4 squared is going to give me a 20. Take the square root of it, that's the square root of 20, right? And then I'm going to do the same thing for here. I'm going to make a right triangle and use the Pythagorean theorem to figure out the distance from these 2 points. So here we have a 5 for one leg. Here we have a 4 for another leg. And we have to think about what 5 squared plus 4 squared is equal to. And that is going to give us the square root of 41. So we have our A, square root of 20 squared. We have our B, which is square root of 41 squared. And our C, which is 8 squared. And 8 squared is 64. And we have square root of 20 to the power of 2, square root of 41 to the power of 2. And 20 plus 41 is not equal to 64. So this is not a right triangle. So this one here, we need to solve for x. And the first thing that I need to do is just get rid of my denominators altogether. I gotta just get rid of those. And so I'm going to multiply both sides by the least common multiple of the denominator, the LCD. So that means I'm going to multiply both sides by 18x. Okay. So I've multiplied both sides by 18x, but I have not actually distributed in, because the whole point in me multiplying both sides was so that I could get rid of my denominators. 18x here crosses off with 18x, and I'm left with x minus 2. 18x divided by 9 is going to give me a 2x. I got rid of the denominator. 18 divided by 9 is 2. X will cross off with x. So we're left with a 2 times x plus 1, which gives us a 2x plus 2. And at this point, we need to solve, and we will get a x is less than or equal to 4, which means that we're going from negative infinity all the way to 4, including the 4. Alright, we want to find the equation of the line that contains the points. So we need to start off by finding the slope. Okay, so that's a great slope to have because we don't got to deal with a fraction. And what I need to do is plug that slope into my y equals mx plus b form and solve for the b value. Remember, we just need two things for the equation of a line here, the slope and the y-intercept. So I'll go ahead and plug in my point when x is 1, y is negative 1. So we end up with a b value that's equal to negative 2, which means y equals 1x minus 2 is the equation of our line that contains those 2 points. Okay, on this one, we want to find the equation for the line passing through the point and perpendicular to that particular equation. So since I'm talking about perpendicular lines, I need to figure out the slope of this particular line. So let's solve for y and identify that slope. Okay, so solving for y gives us y equals 3 over 2x minus 5 over 2. And since I'm looking for a slope that's perpendicular, I need to take the negative reciprocal of the slope that we have. So I flip the 3 over 2, I have a 2 over 3, and make it negative. Now from here, I need to find the b value for y equals mx plus b. We have the slope, it's negative 2 over 3. So I'm going to plug in my point and my slope and solve for b. Okay, so I've solved for b here, and now I have everything I need for the equation of a line. We got a negative 2 over 3x plus 7 over 3. And that is our equation of our line that's perpendicular to this given line that passes through this particular point. Okay, I know I'm going fast here. We need to complete the square to solve for x. So the first thing I need to do is just isolate my x terms to one side. So I'll pull the 9 to the right. Next, I need to get rid of the coefficient in front of the x squared. It needs to be a 1. So I'm going to divide each term by 4. Now I need to look at my b value, cut it in half, and raise it to the power of 2. So I'm going to add 1 to both sides. 2 divided by 2 is 1, to the power of 2 is 1. So I add 1 to both sides. I need a common denominator to add those numbers on the right. So I'm going to have to multiply the 1 by 4 over 4. 4 over 4 is just a fancy 1. So we have a 13 over 4. And on the left here we have what's called a perfect square trinomial. At this point here, I can square root both sides and solve for x. Skip a few steps here. And voila, square root of 4 is 2. Okay, let's see if we can't finish one more before my time's up. Okay, quadratic formula to solve for x. We have to pull everything to one side so we have 0 on the other side. And now we have a form where we can use the quadratic formula. We identify our a, our b, our c values, and then plug them into the quadratic formula. Now that I plugged everything in, I need to simplify. Okay, so here we have the square root of 28, which simplifies to 2 root 7, because square root of 28, that's like saying 4 times 7 square root of 4 is 2. Now we have to simplify what x is equal to. Let's factor out a 2 from our numerator. And we end up with our final answer there in blue. Now, I sped through this. I realize that, you guys. I was trying to cut the 15-minute marker, and I'm not going to do that. I'm going to have to put the other problems on another video for you. Please feel free to ask me questions in class, and I'll talk to you later.